Yeah. Okay, so my name is Jonathan, Johnny Time on YouTube. This is my stage name, and I'm an educator in the space. I'm creating a lot of content out there, both on YouTube, LinkedIn, Meetup, X. Feel free to follow. A lot of video tutorials, courses, and so on. I'm coming from a cybersecurity background for 12 years, starting from the IDF. Then I was teaching a bit in John Bryce. If you guys took some courses there about cybersecurity, through the background all the time there was Web3, but it was something like side thingy. I was always excited by the technology, and like I think Roy said before, now I'm doing full-time Web3 for a while, and when I do that, I don't feel like I'm working. I feel like I'm playing. I used to play a lot of computer games when I was a kid, and for me, I feel like I'm playing in the real world, and so it's fun. I did a lot of DeFi back then, a lot of DeFi content as well, different strategies, delta neutral, staking, liquidity providing, and so on. And in the last 4 years, I'm focused on smart contract security. I decided to look my experience in cybersecurity and blockchain and kind of combine it, especially when I saw there is not that much good training programs, educational programs out there. So I kind of like, how do you say it in English? And recently I am exploring also some MEV background fun stuff. So if some of you are doing things around block building, searching, feel free to come to me after. I'm the founder of Ginger Security, which is a Web3 security firm, a smart contract auditing firm, any security services. I'm the creator of the smart contract hacking and the Cairo darknet hacking course as well. We'll talk about it a bit later. But first, please raise your hand if you heard about the recent Bybit hack. Yeah, I guess most of you did. That's insane. $1.5 billion were stolen in this hack. Bybit recovered somehow, we all know. But this is a screenshot from DeFi Llama. It's a specific section, if you know DeFi Llama, there's a specific section about hacks. And you can see that it's not listing everything, but you can see that every once in a while, 50 million, 1.4 billion Bybit, 500,000, like money is literally stolen almost every single day. This is just the big cases, okay? But money is being stolen in Web3 every single day because of security breaches. And then there is this whole industry called Web3 security, which is some kind of deviation from cybersecurity to the Web3 world. And now I want to ask you guys, what do you think is Web3 security? Please feel free to raise your hand. Yeah.
What I think Web3 security is? I think now it's mostly about smart contract auditing, verifying that the logic of the smart contract is correct. But more generally, it's about everything in the process, whether it's like in the wallets of the users that they use an application, they're not with a malicious content, up to like, I think the concerns of blockchain, it's very decentralized. Maybe it's a lot of things.
That's a great answer. So Web3 security is a lot of things. It started from like smart contract auditing. That was like back then when Ethereum started and people started deploying smart contracts, and there was a DAO hack and money was stolen. And then it got way more complicated, right? Because in traditional cybersecurity, we have incident response, we have penetration testing, we have SOC, and slowly people figure out that we need those things as well in Web3 security, all these emergency operations. Suddenly there are like 1,000 different blockchains, different ecosystems, and you need people that know Rust or Cairo or Neuer, for instance, right? So, come again? Mathematics, right? We have this whole zero knowledge and cryptographic and cryptographic vulnerabilities. So everything around security, around blockchains. And the thing is that when you hack a smart contract or a blockchain or a validator, you steal money, you don't steal data, right? When you hack a company, you steal their data, you can modify the data, but when it comes to blockchain, smart contract, you just take the money and it's gone. And immutable, it's irreversible. So the stake is higher here than traditional cybersecurity. So I anticipate that this is going to go bigger and bigger and bigger. And today we're going to understand like what is Web3 security. We're going to have some fun technical hacking challenges. And if you want to learn more and if you want to get started, I will give you some kind of few steps where you can tap into this industry. Either if it's like becoming a better developer, so if you want to transition into like blockchain security, that's also possible. So that's the goal of the talk today. So feel free to ask questions, raise your hand if you want to say anything. I want it to be more like a conversation or like an activity, right? Yeah. First, I want to show you like the opportunities out there, monetary opportunities. This is a guy called Pashot. He's like Bulgarian, started as a security. He was a developer, then he moved to Web3 security. And this is a tweet from 2023 where he's essentially posting that he made around $1 million just by providing security services to clients. And that's another guy. His name is Trust. You can be proud because he's Israeli. He's like ex-8200 guy, and so on. And now he is one of the biggest Web3 security team with an income of $5 million per year. So we can see like there is demand and people are willing to pay money to keep their program safe and secure. Okay, so what is smart contract auditing, which is kind of like the basic of Web3 security? So you write a who here writes smart contracts? Please raise your hands. In which languages? Feel free to say. Solidity. You? Who's writing you?
Who's writing you?
Okay. We have big guns here. Yeah.
What? You? Sorry? You?
Yeah. What else? Someone is writing in Rust or Cairo? Okay. So you guys write your smart contracts and then you write your test, right? You have your...
That's wrong.
That's wrong.
That's wrong.
Right. That's wrong. Come again?
You fired.
I failed.
No, fired.
I'm fired. I'm fired.
That's all.
Okay.
Finish, really.
Yeah. So you're supposed to write your test. Meanwhile,
before you don't write the test, only then you can start thinking about implementation of any content. Otherwise, you fail.
if you write
Zero tolerance for this.
you write tests first and then you write your smart contract?
Always. No, when I play right stuff. Yeah, I can do hotel.
Okay.
It's like TDD, but it's a approach.
No, it's not approach. It's talking about that money. That people know. It's not approach.
Okay, interesting approach. Anyways, you write your smart contract, you write your test, and then what you usually do, you go to an external security firm to get a review, right? You want them to take a look at your code, find bugs, report them to you, tell you how to fix them. This is usually how it works. But there are a lot of things that you can do if you are aware and thinking like hackers, like attackers, as developers, which essentially means that one, security review is mandatory. It's better not to avoid it, but the time that you will be paid to the security reviewers will be used better because you kind of like close all the low-hanging fruits, all the security issues that you already find. And so usually it's like a time frame audit where you give it to a third party. They take a look at your code, they try to break it, they try to hack it, and they give you a report. Then you fix the bugs. You take a look at the report, you fix the bugs, then they check your fixes, make sure you actually fixed it and you didn't create new bugs while fixing it, because a lot of times you change the logic. And these are smart contract auditors or security reviewers, and you have so many companies that are doing those kind of services. And now we're going to break some smart contracts. So Shauli told me that this is a technical workshop. So let's see how smart you are, guys. But we're going to start with some small challenges where you have to take a look at the code. Solidity code, okay? We don't go with you here, no hardcode stuff today, no Rust. Solidity code, and you try to find the bugs. So this is like the first piece of code that I wanted to look at. So if you guys like niche perfumes, this is the new smart contracts of Helion. And they're selling their new fragrance NFT on chain. And you can mint an NFT, okay? And your goal here to hack this function. How would you hack this function? This function is not secure, it's hackable. So how do you hack it? Okay, well, first I will say what is the goal. So the goal is to steal the ETH from the smart contract. So we have here a purchase fragrance function. It's a public pedal function. This is a function that essentially receives ETH and means for you an NFT that represents some kind of perfume, some kind of fragrance. And you can read it for a second. So it's essentially does some checks over here, and it accesses the storage, checks some variables, mean the fragrance for you. And then you have this function, you have refill perfume and withdraw and flip sales state. So the bug is here. Take a look at this code and try to find the bug. Let's see who's first. Who's going to raise his hand first? Okay, 1 second. He raised his hand first. Yes, it's more easy than it seems. Anyone can just call this withdraw function and just take the money from the contract, right? So it's like, this is a classic simple access control vulnerability in smart contracts where you have a withdraw function and we have a required statement that seems to be like, oh, wow, we check something, right? So, but what do we check? We check that the message sender is the address that is controlled by the user. And you will be surprised, maybe not these days, but there used to be smart contracts with this kind of logic, because you can just pass a 2, which is you. So this condition is going to be true, and you can just drain it. So we start with, we are warming up. That's good. Okay, is it clear for everyone? Yeah. Next one, another goal. How do you steal tokens from this token smart contract? Take your time, guys. Malak, there is it? So this is a token, a contract that represents a token, and your goal is to steal tokens or inflate your token balance. A hint, I'm giving you a hint.
You can send to yourself.
Come again?
You can send to yourself, and then deducts and adds to yourself.
What's your name?
Omri.
Well done. Great answer. Okay. So we have something called arithmetic underflow here, which was available in previous version of Solidity. From 0.8, it's not available anymore. But like Omri said, you can send tokens to, you can call the transfer function with your address to yourself. You're sending tokens to yourself, even though you don't have any tokens in the state, in the balances. And because we have here a minus and you have initially 0 tokens, in Solidity, integers, overflow or underflow, in Solidity prior to 0.8. And this is a classic arithmetic underflow vulnerability. So it's also another simple one. These days, you won't see that many vulnerabilities like this. I'm warming you up, guys, and I'm giving you the feeling of what does it look like, vulnerabilities in smart contracts. Don't worry, it's going to get harder. Is it too easy for you? Raise your hand. Too hard? Is it clear? Okay.
Very good.
Okay.
Why they require us to catch it? Never.
Let's take a look. Require get balance minus message value greater or equals than 0, right? So when we get the current balance, which is 0, reduce the value, which could be whatever number you want, 10, 20. This whole thing is going to be a huge number, which is obviously greater than 0. So we pass the required statement, we do this deduction over here, and we do some kind of reset. So we're going to have a huge balance, like the maximum of int 256. So how do you solve it? That's your question? No, it wouldn't solve that.
Make sure the value is not a minus.
Sorry, let's talk about how to solve it. First of all, here, obviously, You add some access control that is actually controlling the access. This is the first one. And here, the solution is first use Solidity version 2.0, which is gonna solve it for you. Or you can do another require statement and check that the previous value, for example, when you deduct the number, the next value needs to be greater. So you have like some kind of assert, some kind of like some kind of another required statement that will make sure that when we deduct value from initial value, it's not going to be bigger than the initial value. It doesn't make any sense, right?
Current value is bigger than the value that you want to transfer.
Exactly.
You have to make sure the current one.
Exactly. So this is how we solve arithmetic overflows and outflows. And by the way, it exists in other languages as well. And now we're warming up a bit more. This is a bit more challenging, guys. Stay tuned, stay tuned. Take a look at this code. And now your goal. So you're eligible to mint the Board API Club, okay? And this is the smart contract where you can mint an ape. And your goal, you have only one ape allocated for you. You wanna mint 10 apes. How would you do that? Take a look at this code, not very long code, very simple. You have a solution? Let's give 1 more minute. Again, your goal, you have allocation for only one NFT and you want to get multiple NFTs. How would you do that? This is a bit more niche. You need to be a bit more like sharper in terms of knowing certain things in the blockchain world, not only in Solidity.
Because you already claim and
yeah, so I'll let
you mean before you.
You're right, but I want to let. Okay, go ahead. Go ahead.
Sorry.
No, go ahead. It's okay.
When you first mean the NFT and only then you publish that it's claimed, so you can.
Perfect. Yeah. So we have a re-entry attack here. Okay. Re-entry attack is something that is very, very specific to smart contracts because of the nature of atomic transactions and so on. It essentially means that you can call a function and then you can re-enter the same function again and again and again and again and again to manipulate the state of the smart contract, right? Anyone who knows what is re-entry attacks? Please raise your hands. Okay. So essentially here, you need to be a core developer and understand how ERC 721 contracts, NFT contracts work. And if you know, as most smart contract auditors know, you know that the safe mint function is a function in ERC 721 tokens that creates a callback to the receiver of the NFT. And why is it dangerous? Because you're entering this function to mint an NFT. We do some checks that you can claim, you're in the whitelist, you can get an NFT, all good. There is an allocation of token ID for you, for your NFT. And then we mint this NFT for you. This mint is giving you the NFT, and then it creates a callback to your address, so you can do certain checks. In this callback, you're not just a normal user, you're a malicious user that wants a lot of NFTs. So what do you do? What do you do? You're a smart contract that enters the mint function again and goes through this code, and then this is called again to get another NFT. Then you call it again, gets another NFT, and only at the end, the function updates the state that you already created your NFT. Only at the end. And because the state is updated only in the end, you can call this function multiple times over and over and over again to manipulate the contract to get a lot of NFTs. And only at the end, it set the mapping to true, which means that, oh, he got his NFT, but the contract doesn't know you got 20 NFTs instead of 1.
So
is that clear?
My
okay, so how do you solve it? Callback is not the answer. We're quite there. How do you solve re-entry attacks? Do you have any ideas? Yeah.
Is it possible to just not give the boundaries for smart contract if only EOA accounts external can call?
Okay.
Is this
yes. Okay. Two solutions offered. Yeah.
That's really good because there's like a certain kind of contract. So in the
also true.
The byte
Yeah.
size is 0. So
okay, so you all offered nice approaches to solve re-entry attacks. This one is the most right and the most proper. That's another option. So there are few ways to solve re-entry attacks. The best solution was offered by Dima, which is essentially, we call it checks, effects, interactions, which essentially means you first do the checks, all the required statements, all the asserts, everything. Then you do the effects, which means you update the state. So then you update the claim to true. And only at the end, you do the interactions. You do external calls to other smart contracts. You do other things where you kind of like letting go, right? Because you are giving control to other smart contracts. But most people don't know that when they use ERC 721 safe means they're essentially making a callback and giving control to another smart contract. So re-entry can come in all kinds of forms. The best way to solve it is follow the checks, effect, interactions. Another solution is to allow only EUA accounts, but this can also be bypassed. Or to do like you suggested, what's your name? Adil, like re-entry modifiers and re-entry guard, which creates some kind of new text, which we check. We won't go to all the details, but just as developers, you need to be aware when you write your contracts, when you create external calls, that this is real. This thing is real and it costs billions of dollars. Okay, literally the first hack, the DAO hack, $150 million was a re-entry attack. Until this day, 2025, we still have re-entry attacks happening every single day in many forms, cross-function, cross-contract, with only re-entry attacks. It happens. Always follow the checks, effects, interactions. Always. Okay, now we're kind of raising the level. So this is more for the Solidity, DeFi, savvy guys. We have a lending protocol, simple lending protocols. Think of Aave, think of Compound, and we have few functions. Deposit assets to the protocol, withdraw assets from the protocol. You can borrow assets if you have collateral, right? You put collateral, you borrow assets. And you can repay if you borrow assets, you want to repay them. And we have this function that checks if your debt is safe. So in order to borrow assets, you need to deposit some assets first. And I will give you a hint. Something might be wrong here, okay? So take a look at the following code and try to find a bug. How can you drain this lending pool with the tokens? It allows depositing one token, and based on its collateral, can borrow the other. Who's going to be the first one to break it? I can give you a hint if you want. Hint time or not yet? קצת לא רואים טוב. אני לא יודע אם אני יכול לעשות זום. You see, I tried my best to make sure to fit as much code as I can in one screen to give you in one slide. Sorry for the inconvenience. Try to get closer, maybe. Yeah, okay, we have a first answer.
It's not like a full attack, but in general, you have this like duplications followed by divisions that can create duplicables. And a way to explain it is maybe use a flash loan protocol to quickly borrow a lot of money in order to skew these collateral calculations. But I'm not like with other functions with actually with the DeFi, I'm not sure like exactly how we work.
Okay. So you said a lot of things. You said rounding errors and you said flash loan attacks, yeah, which is kind of around the solution here, but not quite. I will give you guys another information. Take a look at this is-safe debt function. So this function essentially checks that, hey guys, you put enough money in the contract so you can borrow it. Calculates the ratio between the tokens. And how does it do it? Yeah?
The pair is like,
okay, good question. So what is the pair? The pair is the Uniswap V2 pair. Okay, that's a good answer. Good question, and this is the follow-up answer. So we have a pair here.
yes, you can manipulate it.
Okay, how do you manipulate it?
Using a loan or something, you can whatever, like in the block, take the loan, start it.
Okay, great. So here is your hint. First of all, the bug.
Make it think that like change the price and then go to the lending protocol and then go back and hand back the loan, and it's like an oracle attack.
Yeah, this is called an oracle manipulation attack. Okay, so this lending protocol, every time if you pay attention, it calls this is-safe debt function. This function is essentially taking the token and the user. It checks how much collateral the user supplied, how much money he put into the contract, then it tries to convert it to the other token, and then it says, hey, I can give him only 66% loan to value. So if you deposit $1 of ETH, you can borrow 0.66 cents of USDC, for example, right? But the way it does it is not the best way, because what it does, it interacts with this Uniswap pair, Uniswap V2 pair, AMN. Okay, it takes a look at the current balance of these two ETH and USDC tokens, and then it does this simple multiplication of reserve 0 and dividing by reserve 1. So it kind of converts your deposited assets to the lending pool based on the Uniswap pair reserves. And this is a huge no-no. Why? Because, again, to be a smart contract security researcher, you need to understand DeFi and how lending protocols work and how AMMs work. And if you know how Uniswap V2 works, you also know that if you tell Uniswap pair, hey, I want $5 million right now, I give you nothing in exchange. I give you nothing. I just want all your liquidity right now. Give me all reserve 0. I want $5 million of ETH right now. It will just give it to you. This is called flash swap. Essentially, Uniswap doesn't care if you give it something in exchange, but at the end of the transaction, he will give you a callback, and in the end of the transaction, he will check that you paid back the money with a fee, which is usually 0.3%, depends on the fork. Okay? So if this lending pool is basing its price oracle on this pair, that at any point of time you can just take all the money of one reserve, you just go to the pair, you tell him, hey, give me all your ETH, so it's going to have 0 ETH and 5 million USDC, and we do this calculation based on this manipulated reserve. Then we can deposit how much? Just 1 USDC and borrow 100 ETH, right? Because we took the ETH from the Uniswap pair. Sorry, we took the ETH. We didn't give any USDC, so there's a small amount of ETH, a lot of USDC. What happens to it? Becomes super expensive. No, because you took the ETH, you supply and demand, right? You took the ETH, the price of ETH skyrockets. This lending pool thinks that one ETH costs $1 billion. They deposit just one way and take all the USDC, right? So this is how it works, historical manipulation. So this is the attack. We have a proof of concept, a POC, right? So we have a smart contract that attacks this lending pool. What it does, it first, in step 1, requests a flash loan, tells the Uniswap, hey, dear Uniswap, I want to get all your ETH, right? Just for a slight moment, don't worry, I will pay you back. I will pay you back at the end of the transaction. It all happens in one atomic transaction. That's why these attacks happen in seconds, in milliseconds, and we don't have time to react. So we request here a flash loan, right? And then we get this callback from Uniswap. We get a callback. We got the money. Uniswap gives us the money, and now calls to our function. We got this Unicode, this callback. What do we do with this callback? First, we call deposit. First, we call deposit. Yes, exactly. So we call deposit. We got a lot of money from Uniswap. We deposit just a small amount, right? Just 0.1% of the money that we got from Uniswap. We deposit it to the broken lending protocol, right? And at step 4, just with this small 0.1% liquidity that we got from Uniswap, we borrow all the other token, and then we pay back Uniswap. Now we need to pay 0.3%. I was IT large, I paid 0.4%, but it's way more than enough for me to keep all the profit that I drained from this broken lending protocol. So this is a classic Oracle manipulation attack, and you will be surprised that these days they're still being exploited in the wild. So if you understand it, you already have value as a developer. If you work with DeFi, with lending protocols, with AMMs, if you want to become a security researcher, you might audit and take a look at this kind of broken code and tell to the developers, hey guys, here doing something wrong. And now we'll take another
solution. Are you going to talk about the solution?
Solution, yeah. What's the solution?
Use Oracle that is separate from the ratio between smooth pair.
Okay, so what do we do as developers? How do we kind of avoid this Oracle manipulation attack? There are plenty of solutions, but there are different approaches that are considered safe. For example, like you said, we never calculate the price of two assets, the ratio between them, based on a single pair, because a single pair has thin liquidity. It can be manipulated with flash loans, with flash swaps, right? So we want to rely with our price oracles need to be more resilient to volatility, to oracle manipulation attacks. So we can use oracles like channeling, right? External price feeds. We can also use something called swap time weighted average price. So Uniswap has a feature that the pair contract gives you the price, not the spot price, not the atomic price right now, but it stores it over time, creates some kind of average, and give you an average price. This also can be manipulated. We don't have like, guys, this we can talk about it like for I don't know how many hours. We're trying to make it to the point to give you like a taste of this world. But these are the best solutions to this day. Like use multiple oracles, use external off-chain independent oracles that can be verified on-chain, use swap oracles, sometimes combine them together. Every approach has its pros and cons, okay? So I'm wondering if we should make it even harder, or maybe we can skip, because you got the idea of challenges and oracle manipulation attacks. Who votes for spice it up and get it harder? Who wants to move on with the chart? Okay, that's enough. You know, I got like a governance proposal passed. Okay, so let's spice it up. So the developers,
All the votes were delegated to me and Ram, and we wanted to continue.
So the developers, they got your security report and are like, okay, now we fixed it. But they didn't, right? So if in the previous example, we could take a flash swap, and we could manipulate the balances of the pair and so forth, manipulate the price. Now the developers, instead of just checking the ERC20 token balance of the pair, they are accessing this get reserve function. And I will tell you that this get reserve function of reserve 0 and reserve 1, now we retrieve the reserves in a different way. It's only updated at the end of the transaction. For example, after you pay the loan back. So you cannot take a flash swap and manipulate the prices. Because if you take the flash swap, yes, you change the balance of the ERC20 token of the pair, but the get reserves function is going to return the previous balance before you did this operation. But you still have a way to hack it. So how?
I think you can borrow without depositing, no?
No. Other ideas? No. No. Not the block bidder, not.
I said about the solution. I think that's the
Sometimes, not always, but no. Okay, so we cannot use flash swaps on Uniswap to manipulate this function because, again, we are relying on this get reserve function that is being updated only at the end of this swap. So how would you still hack it? You can still hack it and take the money from the smart contract.
You said you can just manipulate it without a flash loan.
Okay, how?
Slower. Just do it regularly. You found just to take a loan in from the reserve. And
but if you take a flash swap, the get reserves is like before the state before your swap.
Yeah, do it in a couple of transactions instead of one transaction.
Okay, that's one solution. But if you do it in a couple of transactions, how do you pay back the fee? You get $1 million liquidity. You need the capital, right?
You need some.
Okay, so with capital, right, you can still do it because you can dump the parent token, dump the price, come with a big capital, take all the ETH liquidity from the pool, right? Like buy all the ETH, manipulate the price, and then execute this attack on this broken lending protocol. That's one solution. Use external capital. I will tell you more things. In reality, it's not gonna work because of this guy and MEV and sandwich attacks and all these kind of things. Because once you make this huge swap of ETH, someone is gonna arbitrage it and balance it with other pairs. So you need to do it not only in this pair, but in all the pairs in the chain, which requires a lot of capital. It's possible to require a lot of capital. There is an easier way. So challenge accepted. An easier way to avoid MEV implications, to avoid without external capital, with zero money. I can still hack this protocol with zero capital. Think. I mean, I do need a capital, but it's not supposed to be mine, okay? This is a hint. Flash loan attacks. Okay. So we're talking about flash swap, where we take the capital and liquidity from Uniswap. We take a flash loan from Aave, from Compound, from Morpho, from whatever, from another Uniswapper. We don't care. You get a capital for a slight atomic moment. Then you perform a swap. In all happens in a single transaction. You still manipulate the reserve because you completed a swap. You didn't take the loan from Uniswap. You took it from somewhere else. You executed a swap. You manipulated the reserves, and then you the generous way to bet the price Oracle can be innovated through using flash loans from another protocol. So we get a loan from Aave, okay? So we use an external capital, not from Uniswap. We take a loan from Aave over here. Then we get a callback from Aave. Aave is the biggest lending protocol out there. We get an execute operation callback to our smart contract. What do we do with this capital we got from Aave? We swap. We dump it. We dump it to this pair. We swap it right here. We use here the router. With the previous one, we use the pair contract. Now we use the routing contract. We swap the tokens. Then we swap the tokens. What happens? The price drops. We manipulate it. We change the price. So now we can shrink the lending protocol. We can deposit a really small amount and borrow the other amount. So we borrow, then we swap back, then we pay back the loan and live with profit. And the lending protocol balance is going to be what? Zero. Okay. These are attacks that are not that simple. It's not access control. We did it gradually. We started from some simple access control. We talk a little bit about arithmetic overflow. But these are real attacks that are happening right now as we speak in the wild. And this is a 9.4 million hack in recent November. Holzer Finance on Phantom. Just what I showed you here literally happened on chain. Hacker walked away with $9.4 million. And you, the users that deposited money to get yield on your USDC, you can dream about your yield and you can dream about your capital because it's gone. It's now in the attacker set. So this shows you like this is critical, right? It's not just also cybersecurity is critical. That's why I'm doing Web3. It's way more critical than cybersecurity, in my opinion. And here you can see it. And these are just 4 chapters from the smart contract hacking course. I was the first one to like take this thing called Web3 security and create a complete training program because it didn't exist like 2 years ago. And I tried to bring my experience from the IDF, from John Bryce, from Singapore, and create the best training program for security researchers, for developers to become better developers. And we have these kind of chapters. So we have a lot of chapters which are just lectures and exercises. I truly believe in hands-on practice. So like these challenges that we had now, you learn a little bit by listening to me, but you learn better when you actually sit in front of the screen, break smart contract, and maybe also break the keyboard on the way because it's sometimes very challenging. So every chapter here comes with some hands-on exercises and challenges. Some of the things that I showed you are some examples from the re-entry attacks chapter, from the arithmetic, underflow, access control, and Oracle manipulation, but we have way more attack vectors and pitfalls. And this is just the tip of the iceberg of this world called smart contract auditing and security. We also have CTFs, which are very fun way to learn security. So you can go to damnvulnerabledefi.com and for free, if you don't have the capital or time to invest in a course or a complete training program with a certificate and community, you can go to damnvulnerabledefi, break some challenges. If you get stuck, you go to my YouTube channel. I have tutorials step by step how to solve every single challenge. But don't go there. Try to break it first alone. Another one, Ethernet, a great challenge by Open Zeppelin, great company in the space. You have here 33 challenges that will teach you how to break and hack smart contracts. Again, you can check my channel for solutions, for tutorials. Now, what do you do with this knowledge? Okay, how does this space look like? First, you get a better developers. That's one. Because developers or DevOps, whatever you are, if you know security, your value is already higher. You already have an edge on your competitors, right? That's one. Second, you can apply to auditing firms. Okay, this is just example. We have hundreds of them. We have this. We are Digital Security. You have Open Zeppelin, Nethermind, and your job is going to be research, look at smart contracts, try to find these hacks, try to find these bugs, report them to the devs, and the pay is pretty nice. There is really nice salaries because the stakes are high. Okay, if you want to choose like an independent path, you can go to bug bounties. So protocols are willing to pay a lot of money if you find bugs and report them, right? Because they don't want hackers to exploit them and steal $9.4 million. Yeah.
How many developers they hire per year?
Sorry, come again.
How many developers or security researchers they hire per year?
Who is they?
Companies, all of them.
I don't have this information, but you can ask GPT. That's a great.
Not so much.
Okay, maybe there are hundreds of companies, and actually I have a screenshot, not here, but of opening roles in Open Zeppelin. Currently, I think they hire like 8 positions for security researchers, but only if you're good, because if you're a newbie, they're probably not going to get you. So you need to get some experience. You need to learn it a little bit, but there are a lot of openings. But now I'm going to show you the opportunities, not only like to go to the like a salary kind of full-time job, but there are also other opportunities that people are enjoying and contributing to the space while making money. So bug bounties are one of them. We have Immunify, which is a great platform, and you have all these great protocols. I think also Aztec is one of them, right? In Immunify, not sure.
Oh, yeah.
No idea, but maybe layer 0 if you want to exploit some cross-chain vulnerabilities or reserve protocols. Sky is previously Maker, rebranded, and we have Stargate. So you can find a bug and win up to $15 million. Obviously, it's not going to be easy. You're not going to open your laptop tomorrow, take a look at the smart contracts of layer 0 and land a critical and get 50 million. It's way more complicated than that, but there are some people that are making millions of dollars just by doing bug bounties. It's there, but these are like the top of the top. Just showing you how it looks like. And this is another platform, Hackam, that hosts bug bounty programs. Another cool thing that actually I never seen in traditional cybersecurity, but I was exposed to in Web3 security is something called auditing competitions. Some of you heard about auditing competitions, please. Yeah, you want to talk about this?
Well, I actually thought it's basically very much like bug bounty, but with the idea of competitive time frame and the rules are a bit different. But as far as I understand, it's basically gamified bug bounties.
Okay, yeah, it's quite similar to bug bounties, but who knows what the difference between auditing competitions to bug bounties? Yeah,
I guess it's before release, like
exactly.
Container, for example.
Cantina, Coderina, Sherlock. So before we deploy the smart contracts on chain, instead of going just to a firm, we go to Cantina, to Coderina, and we tell them, hey, we want 100 security researchers to look at the code. And they host an auditing competition where you have all researchers coming all over the internet, all over the world, try to find bugs, report them, and then you have judges that check if it's legit or not. And then you have a prize spot. So if you find a bug, you get paid. And it's all on-chain, open source. You don't need KYC mostly. You can just open your laptop, start finding bugs, participate in competitions, and get paid and contribute to the space, which is cool. It's going to be probably easier than bug bounties because with bug bounties, we're talking about protocols that are already on-chain with money in the smart contracts. These are contracts that are yet to be deployed, and this is very cool in the nature of Web3. That everything is open source and free and awesome. Yeah.
The biggest advantage that bug bounty should be the third one. And kind of competitions you usually participate. Times you can try to find this because if you do this one guy it's better go.
That's a great point. With bug bounties, you need to be the first one to find it because if someone found it before you, then you're only going to be paid.
Maybe second, because you can the first one can wait until they go to production and just try to hack them.
Yeah, there are all kinds of interesting things that can happen. But with auditing competitions, it's important to understand that you have a chance, because even if you found a bug and 50 other people found a bug, or you found it later, you still get a share because the price is being divided by all the people who found the same bug. You wanted to say something? Yeah.
Okay, I just wanted to ask, like, how often the bugs are being found there? Like, the company comes and I guess they're.
You're talking about competitions or bug bounties?
Yeah, competition. They say like this is an open arena for some period of time, and I guess the companies don't want to pay the money because if nobody finds the bug, you don't pay the money, right? So they tried to audit before. So I wonder how often people just think they're.
So it's a long story. What you're just saying, it's a pain point actually in the industry, because it started to be like as a solid price pot of, like, let's say $200,000. People come, they break the pot, and that's it. The company already paid, the platform got their commission, and the people get the money based on their findings. But now we have all these conditional price pots, which is a bit weird, and people don't like it that much. There are certain platforms that do it, where they say that only if there was a critical vulnerability, then we pay $2 million. But if there is only high, then it's only $200,000. So they promote it as like a $2 million competition. They bring a lot of eyes, a lot of security researchers, but eventually they pay only 200K.
They decide what is.
Yeah. But so you need to be very careful. Of course, once you dive into these platforms, you will learn the ins and outs and all the you know, הנקודות הקטנות, השורות הקטנות. Yeah. So this is how it looks like. And we have Code Arena, which is the OG in auditing competitions. You can see that currently we have $50,000 competition. You can contribute to Seal Finance, a great lending protocol, find bugs and get paid. You can work in Tor Wallet, 3K, 150K for StarkNet. Okay, we have some Israeli representation over there. Cantina, if we told about the small lines, they promote very high price pot, Eigenlayer, $2.5 million. Pump.fund, $2 million, Ethereum Foundation, $2 million. But you have to read the small notes and the small lines, because it's only the critical fund. And I mean, they're known for like promoting high price pots, which is actually real if you find a critical.
It's also post-audit most of the times.
Yeah, and usually Cantina, protocols derived to Cantina, they've been through like many audits of a lot of firms. So this is like the last step. So it's way harder to find bugs. Also, Unify, the bug bounty platform, started doing competitions last year, so you have a lot of competitions. What I'm trying to show you that there are plenty of opportunities out there. You can choose whatever you want to do, and what I love about it is the nature of that it's open. It's literally open. You can go anonymously, just connect your wallet, go to a competition, get paid, no KYC, nothing, because we are in Web3, and you help to the ecosystem. Of course, I always tell my students, never be black hat hackers. Don't be bad, please be good. It doesn't work always, but I hope most people have the good in their heart, and they will use. With great powers comes great responsibility. So some people choose to do bad things with it. Some people choose to do good things with it. I believe that you guys are going to choose to do good things. So, Mazen?
You can be gray hat.
Yeah, gray hat. Gray hat is also a gray area, you know. There are some people who, you know, they come to a protocol with $200 million. They take the $200 million, use the bug, and they send a message on chain. Hey guys, you want your money back, but we want 10%. And so some people call it like white hat, gray hat. Some people call it ransomware, like ransom, blackmail. Security payment, but it happens a lot when you see hackers come, they hack a protocol, and their excuse like, if we wouldn't hack it, no, someone else would hack it, and he would take the money, and we would never tell. But we're just willing to give 90%. So, and sometimes even protocols offer themselves. They're like, when a hack happens, they send a message on chain to the wallet. It is the EOA wallet associated with the attack, and tell him, hey, we saw what you did. If you want a chance that we will stop pursuing legal actions and go to police, please return the funds to this and that wallet. And it happens. There are these deals made it way. I wouldn't do it. I think it's in the gray area, if you ask me. But there's also a lot of frustration with why did hackers go through a Unify and a lot of processes and they get screwed. So it's a complicated, you know, I'm not a lawyer, but maybe there is a law firm here and they can help you with. And it's kind of also a karma thingy. So yeah, so it's a very competitive space. I'm not telling you that tomorrow you get there and you make $50 million. Also, there are plenty of companies that are doing competitions, bug bounties, security services, just giving you like the transparent landscape of how it looks like. But of course, always there are opportunities. In every market, I'm doing MVP. We see competitors all the time on chain, and we still make money, okay? Trust, oh, Bahou Israeli started from, not from nothing, okay? He was finding bugs in NSO, but he is one of the leading people in the space. I also started from nothing. Now I have almost 30,000 subscribers and one of the best course in this industry. So everything is possible. Depends on you if you grind, if you're serious. This is a great website. It's called Daily Warden, and it lists all the competitions simultaneously on a calendar. So the best time to join to a competition, when you see like 20 competitions simultaneously, it means that you have less competition, right? Because the security researchers are spread over a lot of platforms. But on the other hand, if you have a protocol and you book an audit, make sure to go to this website first and check that your audit time is not here. If you go to public audit competitions, because it means that less people are going to look at your code, less focused, because there are a lot of opportunities out there. So it works in both sides, supply and demand. The cool thing is also that reports are public. So once you get to the next level, you got the basics, you can read them. They are open. You can read all the bugs that were found. You can learn from that. There are websites that scrape all this data, and you can search based on protocols, based on severity, and so on. This is called Solid. This is the website. So you can look at any bug that was found on any audit by audit firm, by competition. And how do you start? First, fundamentals. I guess most of you have the fundamentals. You're probably Solidity developers. You know how blockchain works. Now you need to learn how to hack and break smart contracts, right? All the reentry, lending protocols, Oracle, DAO attacks, and so on. Plenty of free resources out there. If you want the shortcuts, take the training program, take the course, join the community, take the certification, everything in one place, hands-on oriented. If you don't want to, go to YouTube, go to Medium, follow me on X, a lot of free content out there. I always recommend people learn in public because you want to create a brand and a name for yourself. So you want to share your journey on X, on LinkedIn, on Meetup, on YouTube, right? And stop watching videos. Do some actual things. Break contracts, write contracts. I mean, it's fun sometimes to watch someone doing the things for you, but I always prefer hands-on practice. And that's also how I built my course. And right away, sometimes even students are taking the course and then they do competitions and bug bounties at the same time. And sometimes meanwhile the course, they didn't even finish the course, they share it in Discord that, oh, wow, I made 5K because I was the third. I found this unique bug in this and that competition. So hands-on is always good. Get experience. That's the most important. So you can literally today go to CTFs. You can go to competitions. You can do the bug bounties and start practice. Questions? All clear? So feel free to connect with me on YouTube, LinkedIn, Twitter. Thank you so much.